We are now going to talk about classification of matter. Matter is everything that makes up our physical world, and we can classify it in different ways. The first type of matter that we have is pure substances. Pure substances cannot be broken down into any other substance by chemical or physical means, right? In this case, we have elements, everything that it's in our periodic table, and we have compounds like manganese dioxide. So those two things, for example, make up pure substances, and we can break them down. Another example about pure substances is an element, right? So in the previous slide, we had an element that was gold. In this case, we have an element that is either copper or aluminum. An element, it is an identical atom. So even though we can have sheets of aluminum or wires of copper, we're still talking about copper, 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 copper throughout the wires. So it is identical. The composition of that is identical. On the other hand, in pure substances, we can also have compounds. In this case, a compound is composed of two or more elements in a fixed ratio. In this case, the very important word here is fixed ratio. For example, here we have table salt. We know that table salt is NaCl. So it is composed of one atom of sodium and one atom of chlorine. If we have NaCl2, this would not be salt because it has to be the fixed ratio. The properties differ from those of the individual elements. For example, in this case, table salt, sodium is a very reactive metal, and chlorine, it's a very poisonous gas. So we have a very reactive metal, and then we have a poisonous gas, and put together, they make up table salt. And table salt is very useful for the biochemical reactions that make up our body. So again, two very important things about compounds. They have a fixed ratio, and the compound does not have to have the properties of the individual components. It's actually the other way around. Pure substances, as I mentioned before, follow the law of definite composition. A given compound always contains the same fixed ratio or element. Two different compounds, each has a definite composition. So for example, in this case, we have carbon monoxide. Carbon monoxide is CO. It's made up of one carbon and one oxygen. Carbon monoxide has different properties than carbon dioxide. So even though they're composed of the same thing, a carbon and an oxygen, they make up two very different compounds just because of the amount of oxygen. So they follow the law of definite composition. In this compounds, we can have, well, compounds are either made by ionic particles or molecules, depending on the type of bonding that they have. A molecule is two or more atoms bound by a chemical bond that is not ionic. They can be two of the same element. For example, we can have water. We know water very well. Oxygen, that maybe we did not know this, but oxygen is a diatomic molecule because you actually need two oxygens to make a molecule. Hydrogen follows the same thing, as does nitrogen, as does chlorine. CO2, we already talked about it. It's already a molecule. So let's see what makes up pure substances in the form of compounds. In this case, we have water. Water is a molecule that is a compound because it contains more than one element. Water is made of H2O. So in this case, it follows the law of definite composition. A water molecule always has this composition, and it is a molecule. Ordinary salt is a compound, but it's not a molecule. It's actually an ionic particle. Why? Ionic compounds have very specific definitions. In this case, we can see the lattice. The lattice are sheets of very well put together arrangements of atoms. In this case, sodium is a purple molecule and chlorine is the green molecule. A molecule but not a compound is ozone. Ozone is O3. It is not a compound because it contains only a single element. So we can have compounds that are molecules, compounds that are ionic particles, and elements that are molecules but not compounds because they are only made up of one element. As I mentioned before, diatomic elements are molecules. In this case, my diatomic elements, so they need two to be together. They do not exist just by H. We have H2, N2, O2, and all group 7 it's a diatomic molecule. So we find these types of elements like this. If we have an I, only an I, it's not going to be iodine, it's going to be a radical because in order to exist, it needs to be paired up. Very important. Both elements and compounds have a definite makeup and definite properties. So we were talking about this too. So elements, remembered, are made only of atoms. Atoms are bonded. It's either diatomic or polyatomic. Then we have compounds. 2 or more kinds of elements are bonded. And we have not talked about this. We have mixtures, which is 2 or more substances are physically mixed. So look at this. We start with an element. They can exist by themselves or they can make compounds. And compounds, then, if you mix more than one, we can have mixtures. So let's talk about mixtures. Mixtures is what we encounter most of in the world. If you think about anything that you use, most probably it's going to be a mixture. Starting from our breakfast, some scrambled eggs, for example, it's going to be a mixture of ham and eggs, or a mixture of eggs and a little bit of oil in any way. If we think about the shampoo that we use to take a shower, or the shoes that we wear, or the clothes that we wear, most probably they're going to be a mixture. A mixture, it's a variable combination of 2 or more pure substances. Each one of them keeps an individual property. Not so when we were making compounds. We said that, for example, salt came from a very reactive metal and a poisonous gas, and they make up new properties. In the mixture, the properties are kept. For example, we have the example of apple juice. In apple juice, the properties of the apples are kept. For example, its taste, and the properties of water are kept. For example, that it is a liquid. So each keep their individual properties. We can either have heterogeneous mixtures. Remember that hetero is different. So we have heterogeneous mixtures when we can see the different parts. So in this case, we can see the black spots, that is one mineral, and the gray or pinkish parts, that it's another mineral. In a homogeneous mixture, It says evenly mixed, and we cannot see different parts. Remember that homogeneous is the same. So in this case, we cannot see where the apple starts and where the water starts or the sugar starts. Everything is evenly mixed. We can have mixtures that are solutions. So we have a homogeneous mixture or a homogeneous solutions. It has a very small particles. The particles do not settle. Don't settle means that even if you left them for a very long time, you would not see them at the bottom of your glass. Example would be rubbing alcohol, which is the alcohol that we use in our homes to cure, for example, if you have a cut in your skin, we use that rubbing alcohol. Or air, something that you may not know, it's that air is a mixture. Air is actually composed of oxygen, and oxygen at 21%, 78% nitrogen, and 1% of other gases, carbon dioxide, humidity, which is water vapor, or any other gases. So if we have a bag of air, we know that even if we let it rest for a long, long time, it won't settle. We do not know when we breathe in nitrogen or when we breathe in oxygen. We do not know. That's why it's a very homogeneous mixture. Mixtures can also be colloids. Colloids are heterogeneous mixture. It's a very small particle in a very big solution. For example, in this case, we have milk. We know that milk is the majority of it is water. Then we have some proteins, then we have some fat. It is a medium-sized particles, and the particles don't settle. So when we have our normal milk that we drink, lactose or delactose or whatever, we know that if we let it rest there, it doesn't settle. We do not have to shake our liter of milk in order to drink it. The particles scatter light. So I can have light, and we can actually see the different composition. For example, some examples of mixtures are milk, clouds, and smoke. So we know that they're different, but we can't see more or less the different parts because they're medium-sized particles. Another type of mixture that we also have is a suspension. We usually encounter this word when we have medicine, right? It's a suspension of this over this, or for example, a lot of times also in makeup, we have suspensions. In this case, we have a heterogeneous mixture. We have large particles, and the particles settle. So that means that the particles go down if we give them enough time. For example, if you have lemonade and you let it rest in your refrigerator, maybe in the afternoon, up here you would have a more clear liquid than in the bottom part. And in the bottom part, we would have the sugar, we would have the lemon pulp, or anything, and any other ingredient that you use. And when we fill up our glass, we usually take a spoon and mix it again, or we take a glass and then pour it again in order to mix it a little bit. Another example is sand and water. Salt water, sometimes if we take, for example, the water at the beginning, at the shore, we have a very mixed water, right? And if we let it sit, we will see that the sand will be at the bottom of our glass. And then the other, maybe sand and some other green material, algae or something, and then we would have very clear water here. But when we pick up our glass of seawater, everything is very, very mixed. So now that we have seen the different types of mixtures, let's see if we can identify each mixture with its proper name. So we had muddy water. Muddy water can be a heterogeneous mixture, right? It could be heterogeneous. Usually we have very large particles that they can settle. So in this case, we have a suspension. Because we can see the different parts of muddy water. We will have some stones, maybe we have some vegetation, obviously the water, maybe some sand, etc. When we are talking about fog, fog is very much like clouds, and clouds, we said, are colloids. Because we cannot see when one starts and one ends, but we know that they're different. When we have clarified orange juice, clarified, it's very important. Clarified means without pulp, so it's already filtered out. So clarified orange juice is a homogeneous mixture. It's just like the picture that we saw with the apple juice. We do not know when the water starts and when the orange pulp starts. Everything is mixed very, very well. So homogeneous, it's called a solution. The last example that we have, it's Italian salad dressing. Every dressing, we see the different components that it has. So we usually have pepper, salt, oil, vinegar, or something. So this is a heterogeneous mixture. Because we have to mix salad dressing every time we take it out of the fridge, it's going to be a suspension because the particles can settle. So it's going to be a suspension. Okay, so hopefully you can follow my examples and you can make some sense of what I was saying. So let's see this last two diagrams that talks about how can we classify matter. So it says, can it be physically separated? Yes, it can. I can heat it, I can magnetize it, I can filter it. Everything is physical. So if I can do that, I have a mixture. Is the composition uniform? Yes, it is. I cannot see when one ends and the other starts. So then it means it's a homogeneous mixture. And homogeneous mixtures are called solutions. So there we have. So now we have the other way. Can it be physically separated? Yes. I can filter it, I can evaporate it, I can magnetize it, something. Is the composition uniform? No, I can actually see the different parts. Then it's a heterogeneous mixture. Okay, so are the particles, do they settle? So here maybe we can put settle. Do they settle? No, they do not settle, so I can just let them rest and they won't settle. If they don't settle, it's called a colloid. If they do settle, it's called a suspension. Okay, so now if I can't physically separate it, no, I can't, then it's a pure substance. So if I cannot filter it, if I cannot evaporate, I cannot distill it, then it's a pure substance. Can it be chemically decomposed? Can I use electrolysis or anything? Yes, it's a compound. If I can't use anything like that, it's called an element. So if I can break it up into its parts, it's a compound. If I can't do that, then it's an element. This is a very, very useful chart in order to classify your matter. Okay, so last one. So in this case, we have a mixture and we have a compound. So how are they alike and how are they different? So let's start with pure substances. We know that a compound, it's a pure substance. It follows the law of definite proportion. So it has a fixed composition. It is bonded between the components and it can only be separated by very aggressive chemical reactions. So how are they alike to a mixture? We said that an element makes a compound and compounds make a mixture. So they involve substances, of course. They contain two or more elements because we're talking about compounds, and they can be separated into those elements. How are they different? A mixture can have a variable composition, and just think about lemonade. Lemonade is a mixture, and it depends on your taste if you're putting more or less sugar, more or less lemon, or if you adding mint or lavender or any other thing that you like in your lemonade. No bonds between components, and that is why we can take it apart with physical means. And exactly, so this relates to this. They can be separated by physical means because the interaction between one component and the other is not as the energy between them is not as high, so we can use physical means. So this is the last part of separated classifying matter. So remember, matter can be classified as pure substances and mixtures. Mixtures can be homogeneous and heterogeneous, and pure substances can be compounds and elements. Thank you for your attention.